Hey everyone, I'm Gil. I'm an architect at Wix, and in this talk, I'm going to tell you how we solved one of the biggest performance bottlenecks in React. At Wix, we render hundreds of millions of websites with React and SSR. SSR gave us great performance, but as our sites got bigger and heavier with content, hydration started becoming a real problem, causing very slow user interactions in Wix websites. The bigger the pages got, the worse the time to interactive became. And for years, we just couldn't solve this. We didn't want to give up SSR, but the interactivity kept holding us back. Until React 18 introduced Suspense API, which made selective hydration possible. And we can finally have both fast page loads and fast interactivity at the same time. In this talk, I'll share how we use Suspense to unlock selective hydration, cut down JavaScript, and dramatically improve user interactions across Wix sites, and how you can apply the same approach in your React apps. I'll go over the main ideas, but also share some real code examples, so by the end you'll understand both the big picture and the details of how it actually works. A little bit about me. I joined Wix almost 9 years ago, and I'm a part of the viewer team. We work on the rendering engine for Wix websites. As a performance architect, solving the hydration problem has been one of my top priorities for years. For a long time, I knew React working on a solution for this, and when React came out in beta, I played around with the new Suspense API, even though there was barely any documentation, only a few blog posts from early adopters. I quickly realized this feature wasn't officially released yet. It was just it was still experimental and mostly used internally by frameworks like Next.js and Remix. It started as a small POC, and a few years later, it became one of the most impactful performance features we've done at Wix. We were able to make real impact on live performance, downloading 20% less JavaScript and improving INP by 40%, which is one of the core Web Vitals measuring interactivity. This is on all Wix production websites. Just to give you some perspective, if you haven't seen this post by Avisha a few weeks ago, Wix websites now have the best core Web Vitals scores out of all the big frameworks. This is obviously not only because of the project that I will present today, but it definitely had a huge impact, and I will go back to this graph later in the talk. Now, before we dive into how Suspense helped us, let's take a step back and look at the basics to really understand why hydration is even a problem and how it's related to user interactions. We need to revisit what SSR actually does well, what hydration is, and why this combination, while very, very powerful, can be a major bottleneck. So first, a quick reminder, SSR, or server-side rendering, means React renders the HTML on the server and sends it to the browser. The benefit is obvious. We get fast initial paint and good SEO. It also gives us the ability to cache entire pages on CDN, which even boosts the page load even more. But then comes hydration. In order to make the site interactive on the client side, the application has to download all the JavaScript bundles and then hydrate all the components that were rendered on the server, basically connecting the server HTML back to the React tree and attaching all the event listeners so components will respond to user interaction. The hydration process is what makes the visible DOM from SSR interactive, but it requires to run JavaScript. On small pages, this is not an issue, but on large pages with hundreds of components, it means massive amount of JavaScript has to be parsed and executed on the browser before the user can make any interaction. Even with concurrent rendering in React 18, if the browser has to download and execute too much JavaScript, interactions will feel delayed. The result is poor time to interactive on large pages, especially on mobile with suboptimal network and CPU, simply because of the amount of JavaScript on the client side. In simple terms, users see the site very fast, but waited a long time until they can actually interact with it, causing a real user experience issue. So the big question is, can we have both fast page loads and fast interactions at the same time? And technically, can we keep the benefits of SSR without paying the price of hydrating the entire page? Let's look at a quick example. Here's Wix.com, a large content-heavy site built with Wix using React and SSR. The page loads instantly thanks to SSR and CDN caching, but notice how long it is. Dozens of sections and components live below the fold. Even though users don't see them right away, the application still needs to download and hydrate all of them before the page becomes fully interactive. That's the hidden cost of hydration, and it's definitely high on large sites like this. You can't see it in the video, but imagine the user trying to interact with any of the components. They would take a few seconds to become interactive on large sites like this. This is a huge issue. So back to the big question, do we really need to hydrate all those components when the page loads? Can we hydrate them only when they enter the viewport and the user can actually interact with them? Well, up until now, we couldn't. When using SSR, React requires us to hydrate every component that was rendered on the server. If you skipped one, React would throw an hydration mismatch and sometimes break the page. Maybe you're familiar with this error by React. The solution is selective hydration. React 18 introduced a new capability with Suspense that finally breaks this limitation. It allows us to hydrate components selectively when the hydration is really needed instead of all at once while still using SSR. So let's talk about Suspense. This is what Suspense used to look like before React 18 in React 16, for example. Suspense was very limited and simple. You'd use it with React Lazy to dynamically load components only in the client side, wrap it with Suspense boundary, and show a fallback while the bundle was loading. And that was pretty much the only use case. In theory, it could be used in SSR, but it would always show the fallback. So we couldn't use it in SSR just because of that. We didn't want to show the fallback from SSR. So we couldn't use Suspense. With React 18, things got much more powerful. Suspense gained the promise-based API that opens many different possibilities, like streaming components from the server when they're ready and controlling rendering. It works both on the server and in the client, meaning no fallbacks from the server like in React 16. And the best part is, this finally allows us to defer hydration and control the rendering process and specifically control the hydration process. So since Suspense let us control hydration, we realized we could use Suspense to selectively hydrate components only when they enter the viewport, which is when the user can actually interact with them. This lets us only download what is needed when the page loads, making the visible components interact way faster. Let's walk through how selective hydration actually works in our setup step by step. And I will show the full code example right after. So all the components are rendered on the server. So everything is visible right away thanks to SSR. But at this point, the components aren't hydrated yet, and their JavaScript hasn't been downloaded. Each component is lazy loaded and wrapped in Suspense boundary, both in the server and in the client. When the app runs in the client, those wrappers inside the Suspense boundary can pause hydration. They throw a promise, throw a promise object that the Suspense catch, pausing hydration for that component. I know it sounds strange, but React decided that this is the way to pause the rendering process. Is actually by throwing a promise object from inside the Suspense boundary to the Suspense component. I'll show it in the code example in just a second. And as I said before, it's not documented anywhere, but it works. The promise will be resolved later when we decide it's time to hydrate. To detect when components enter the viewport, we use an intersection observer, which notify us when components enter the viewport and needs to be hydrated. That's when we resolve the promise and React, actually the Suspense boundary, resumes the rendering process. At the last step, components are finally loaded, hydrates, and become interactive. The result is that components below the fold don't cost us any JavaScript or CPU time until the user scrolls to them. We get the instance paint of SSR, but only hydrates what's actually needed. And React will not throw hydration error because now we return the same Suspense boundary both on the server and on the client and control when they are rendered in each environment. Sorry. And most importantly, we are downloading and executing much less JavaScript on page loads, which makes interaction on Wix sites finally much faster. And now that you understand the concept, let's look at a quick code demo to see exactly how this flow works in practice. The demo covers everything that I spoke about and actually how it works in the framework, the Suspense API, the intersection observer, and how they're connected together. It will be a generic implementation that covers those pieces. It's going to be very technical. I'll go over it fast because it doesn't really matter. But for those of you who want to see the code, I will present the code. And for those of you who don't, come back to me when I'm done, because I have a few more things I want to show you. So I'll go here. So this is a simple React app that shows selective hydration with suspense. The suspense wrapper is a generic wrapper that hydrates children only when needed. And the goal is to download and hydrate the profile card when it enters the viewport. We use dynamic import, so the profile card will be bundled separately from our main bundle. And we use React Lazy, so it will be downloaded only when it's hydrated. Let's dive into the suspense wrapper to see how it's implemented. So this is generic suspense wrapper that will work for any children you pass it. This is kind of like how it works in our framework. So there are three main pieces: the suspense boundary, creating the ref, the promise, and the intersection observer, and also how everything connects together inside the boundary. I know it's grayed out. I will show it in a second. The suspense wraps the children and the suspense inner component, which is just React code living inside the suspense boundary. This is done to make it generic and seamless for all children. So we create a promise that suspense inner will use to control the hydration. We will call the resolver when we want to hydrate the component. Now we create a ref, and we pass the ref into the intersection observer. It's the utility that I wrote. I will show the code in a second. To know when the element entered the viewport, we also pass the callback that resolves the promise when the element enters the viewport. And we pass the promise into the suspense inner to make sure we use it inside the suspense boundary. We have to use the promise inside the suspense boundary. It will not work anywhere else. The suspense inner decides if to throw the promise. Like I said before, this is how we control the rendering. Or return the children based on the promise state. Only in the client side, while the promise is not resolved, it throws the promise to the suspense. This is the React mechanism to pause the rendering process. The suspense component catches the promise, since it was thrown inside the suspense boundary, and the suspense can subscribe to promise events and continue the rendering process when the promise resolves. When the element enters the viewport, the promise resolves, and when the promise resolves, the suspense will re-render the suspense boundary. This will re-render the suspense inner, and since the promise state changed, it will return the children. I know it was fast and it covered a lot. But it doesn't really matter the technical stuff. I just want you to understand the main concepts. Since the profile card is lazy loaded, it will be downloaded and hydrated only once it enters the viewport. And this is the utilities that I wrote just to help me with the intersection observer. We observe on the element. We call the callback when it enters the viewport. And this is how I manage the promise state. Okay, if you lost me in the demo, you can come back to me now. I have a few more slides with some super cool things. So after rolling out this feature across Wix sites, we saw huge impact on real-world performance. This chart shows interaction to next paint, or INP. In short, it's one of the core Web vitals that measure input responsiveness. So in this core Web vitals report, we can compare ourselves to our other major platforms. You can see Wix in the orange line here. Right after we deployed the new feature, we reduced the JavaScript loaded by 20% and INP improved by 40% across Wix sites. And that's just not lab number. This is based on field data, real user interactions across millions of page views. Now back to selective hydration. I want to touch on a question that rises up often when discussing this feature. Why not use server components to solve the hydration issue? Server components definitely can reduce JavaScript downloaded in the client side. But server components, as I said, are great, but they can definitely reduce JavaScript in the client, but they are very limited They must be static, non-interactive, and they can't use context or hooks, which makes them very difficult to use in real-world applications and hard to migrate to, especially for huge code base like ours. Suspense, on the other hand, gives us full control. We can defer hydration dynamically while keeping components interactive when needed. The best part is that the inner components, as I showed in the demo, are unaware of the fact they're wrapped inside the suspense boundary, which gives us a lot of flexibility, unlike several components that the components need to migrate to in most cases. Now let's look at a few extra optimizations that are possible when using selective hydration. Some we're already experimenting with, and some we plan to do in the future. First, we can prefetch component scripts that always appear in the viewport when the page loads. So you can see the search box and the image. They're always at the top, and we can preload them. This avoids the small delay caused by the intersection observers, so components at the top hydrate instantly without waiting for the observer. Second, we're experimenting with different thresholds for observer, tuning when the hydration starts and when the user scrolls to get the perfect balance between page loads, performance, and responsiveness. We also place observers only on containers instead of every small specific component when it makes sense, not to overload the browser with observers. Third, we're experimenting with zero JavaScript rendering for non-interactive components that never need hydration, like text, image, or other components that do not require any JavaScript. So this is similar to several components, but with more flexibility and less limitation. As I said before, for a huge project with tons of components, migrating to several components require a big effort, and with Suspense approach, it becomes much easier. And finally, we're exploring hydration triggered by user interaction other than scroll, things like hover, focus, or clicks. So instead of hydrating components when they enter the viewport, hydration can start the moment the user actually show real intent to interact. This can improve performance even more. Now, lastly, let's talk about React 19, because everything we've seen so far is built on React 18 Suspense, but with React 19 that was released recently, this flow gets even simpler. React 19 introduced the new use API, which brings the same promise-based behavior we use for selective hydration, but in a much cleaner way. Instead of manually throwing promises, React can now natively wait for async values, including hydration, triggers like intersection observer, but also for data fetching or any other async operation that might happen inside the component. And of course, it's now officially supported and documented in React, unlike the older internal pattern that framework like us had to rely on before. So it's the same idea, just looks cleaner in React 19. Let's look at a quick code demo so you remember how we threw a promise in React 18, but now React 19, we simply just use the use API, very similar, and now you understand how it works internally, because it works exactly the same as we saw before, just using use a hook. It's not exactly a hook, but very similar. So this is the code difference that will work exactly the same. We still need the entire framework that we saw before to manage the promise state, because we want to make it generic. Before I wrap up, I want to go back to this post by Avishai, where he mentioned how Wix has now the best Core Web Vitals score out of all the competitors, which include INP, but also LCP and CLS. You can see the full graph here, and you can see Wix at the top. This came after a huge project to move Wix into a multi-page application, which means every page navigation now gets the response from SSR, which means the optimization of selective hydration reaches even more users thanks to MPA. As I said in the beginning, this feature is not the only reason why we're at the top, but it's definitely a significant contributor. And this shows Wix graph alone, which shows how much progress we made in performance in the last few years, which is pretty amazing. And also, lastly, I want to leave you with this. I recently published a blog post on this project, and even Adi Osmani, who helped shape Core Web Vitals at Google, praised the work that we did at Wix. So seeing this reaction by Adi and people like him was super exciting and reminded me that what we're doing here at Wix is very, very, very special. Thank you.